The last problem in this section is 3.29, and this problem goes into the question of manufacturing boxes, and in this case, we're going to manufacture a box that has an open top in it, and say, well, what's the best size of a box? Which size for a fixed volume would give us the smallest amount? Remember, we're going to be following kind of this process that we've been doing all along. We're going to start by drawing a moving picture, and that is a picture. Wow, I didn't ever realize how bad I spelled picture there. Okay, we're going to follow a moving picture, which is a picture that represents not one box, but all the boxes we could draw. So our picture here is going to be pretty simple. It's just going to be a box. And so here's our box, and we'll notice the top is open, so the top doesn't have any sort of top on it. I don't know if those lines make it look open or less open. But okay, so here's our box. Now this is meant to be, the box could be very, very short and very fat, or very skinny and very tall, but this is the box. Now the next thing that we do once we have our pictures, we need to label it. So usually we'd label it with our width. Actually, we usually call this length, wouldn't it? Length, width, and height. What I notice is that this problem gives us one important piece of information, and that is that the bottom is a square. So that means the length and the width have to be equal. So we can label these with the same letter, and we can choose any letter we like. Why don't I choose X? Because I like to have X, and that's because we know that that bottom of the box makes a square shape. Okay, so so there you go. So there's our square shape and X, and H. Okay, now what we're trying to do is we're trying to create an equation. So first we're told what the volume is, but the equation we actually want is the surface area equation. So let's see, can we calculate what the surface area of this problem is? And the answer is yes. To do the surface area, we just have 1, 2, 3, 4, 5 surfaces, and we just have to add them all together. So this front face has an area of X times H. The side face has an area of X times H. Similarly, the two back ones are also XH and XH. And then finally, there's one more to add, and that is the surface area of the bottom. And the surface area of that bottom one is X times X, so it's X squared. So if I want to simplify this, I get 4XH plus X squared is my surface area. Okay, now what we'll notice is that we have two variables, so finally we want to substitute in to get this to be a problem of only one variable. What am I going to substitute in? Well, I'm going to substitute in the fact that I know what the volume is. So I know the volume happens to be 200 cubic inches, but I also know that the volume is length times width times height. So I know the volume is X squared times H, and that X squared times H needs to be 200. So what I'm going to do is I'm going to solve for one of these two variables and plug it in here. It seems to me like the reasonable one to solve for is to solve for H. So H is 200 over X squared, and I'm going to take that H and plug it in right there into that H. Okay, so now I have my surface area equation. My surface area equation is 4x times 200 over x squared plus x squared. Let's simplify that one more step really quick. That gives us 4 times 200 is 800. 800 times, and then one of those x's cancel. So 800 times 1 over x plus x squared. If you wrote it 800 divided by x, that's fine. There's lots of different ways we can write it, but I'm just going to cancel one of those x's. Now, what do I need to do? Finally, I need to find the maximum using calculus. That means I need the derivative. So the derivative of this thing means I take the derivative of all of it. This becomes, well, this is an x to the minus 1, so I could write this x to the minus 1, and then write negative 800 x to the negative 2 plus 2x. Notice this always exists except when x equals 0. So x equals 0 is a does not exist point. But x equals 0 makes no sense in our problem, does it? X equals 0 means that you have a box that has no width and no height, and so that's not a real box, right? That's a line. So So this thing always exists as long as your x is a positive number, as it should be. And so what I really want to do is I really want to solve this negative 800x and the negative 2 plus 2x equal to 0. One real quick thing I'm going to do is instead of writing a negative 2, I'm going to write it as a 1 over x squared. Notice one thing I've done a lot this problem. I flipped back and forth between writing my exponents as a fraction and writing it with a power to a negative power. And I've gone back and forth, and I'm using the one that I think is most helpful for this situation. So when I take a derivative, I think it's useful to write the power with a negative sign. When I do algebra, I find it a little bit more helpful to write it as a fraction. Okay. All right, so the simple thing I'm going to do is I'm just going to add my 800 to this other side. So I'm just going to take this and add that over to the other side. And now what I've got is 2x equals 800 times 1 over x squared. And now I feel like I'm getting pretty close. But let's keep going and see if I can get there. So now at this point, I'm just going to multiply both sides by x squared. And that's going to allow me to not have any more x's on the denominator. And that on the left, that'll give me 2x cubed. And on the right, it gives me just an 800. Let's divide by 2. So x cubed equals 400. And now I see my answer. I cube root the 400. And so x is whatever the cube root of 400 is. I could circle that. Why don't I just type it in and see what that is as a number, just because I'm curious. So that's 7.36. X is 7.36. So that's what I want. That's what I want. If I come over and look at my problem, that's what I want the base of my square to be. I could also find h. H is right here. H is 200 over that cubed root of 400 squared. And so I could put that in my calculator to figure out what h should be to solve this problem. And so h is, let's take that number and square it. And so h is 3.68. Okay, so what you see is I've got my solution now. I have that my base, my square should have been 7, and my height should be 3. So I made it a little bit shorter than I did, so it's a little bit shorter and wider in that way. And this is the way to get the least amount of material used. And you could guess that there are people out there who would really, really care about this. If you're curious, right, 7.36, if you're curious, this number, the height is just this number divided by 2, and that just ended up, being kind of a nice relationship. Okay, so that wraps up the problems. What I hope is as you go through these things, I hope that drawing the picture is making sense. Coming up with an equation can be a challenge, so if you feel like that's hard, sometimes we have to think about a lot of geometry, think about all of our different equations. You're normal if that's a challenge, but hopefully you're able to work that out. Once we have our picture, we start doing our derivatives. I hope that you're able to take your derivative successfully and set up your equal sign, and then doing our algebra can sometimes be tricky. So if you're finding the algebra tricky, you're finding picking the right equation tricky, I would say that's normal. Don't feel distressed, but don't stop either. Keep working at it, and come see me, and we can work on things together. Well, thank you very much, and good luck preparing for the first take-home quiz, which will be coming right after this.